Welcome everybody to Builder Nation. Today we are excited to introduce you to Suind, a company that is transforming agriculture with innovative technology. Suind uses AI, robotics, and advanced sensors to revolutionize crop monitoring and protection, making farming more efficient and productive. They offer solutions that detect crop stress early, diagnose issues, and apply treatments precisely, all with minimal human intervention. Stay tuned as we explore how their amazing solutions are reshaping the future of agriculture. Today, we are joined by Kevin Kleber, co-founder at Suind. Welcome, Kevin. Thanks for joining us today.
Thanks so much. It's a pleasure being here.
Okay, Kevin, well, let's start for the beginning. I know that the other co-founder is Kunal Shrivastava, and I checked some information about him too. And I saw that you both do a master's degree in mechatronics, robotics, and automation engineer at ETH Zurich. Correct me if I am wrong, but in 2016. So I assume that you met there. Tell us what inspired the creation of Suind with Kunal.
Yeah, you're absolutely right. We both actually met during our masters in university, and we were actually working together in the research laboratory, which our company spun out of, the Robotics and Perception Group in Zurich. And we were working like next to each other for quite some time, actually a couple of years before we started the company. And initially, actually, Kunal approached me with his idea to start a startup. He kind of took me out of the blue. I told him I would need a lot of time to think about it. It's a big decision. The next time I told him that I'll do it.
So fast.
Yeah, it was a really cool idea and I loved it. And yeah, we really liked each other. We hit it off from the start. So yeah, I thought, why not do it? Let's take the opportunity. And the idea was really also, we were in this lab and there was so much cool technology being developed. Like we were working really on the state of the art of drone technology using AI, computer vision to make drones like super autonomous. And we really wanted to take this into the world. So we didn't want to leave all this know-how and research just in the lab, basically gathering dust on the shelf, but we want to take it out there and actually make an impact in the world. And after a bit of basically soul finding and market analysis and trial and error, we basically discovered like the agricultural sector for us. So before that, we were not quite familiar with the sector, but after some research, we discovered it really. And for us, and we really noticed there was this lack of technology in agriculture compared to other industries.
Yeah.
For example, in inspection, defense, there's so much new technology being constantly developed and these industries are at the forefront. But agriculture always seems to be a couple of steps back, even though it is an industry that we all really depend on. I mean, all of us, we're eating, so many people work in agriculture, it's the livelihood of so many people, and there's so many issues right now in agriculture. But
the base of
the technology, and the technology is just a couple of steps back compared to what is possible in the world. So with this, we really thought, okay, how can we make an impact in this industry, make it positive towards like sustainability goals, but also in a way that it actually benefits people working in it. So the lives of the actual people working in agriculture.
That's totally true. Yeah. And I want to know that I know that you work for more than 14 years. So I want to know that which skills or what skills you brought into Suind after all these years working. I know that you work as a teacher assistant, then you do research work. And of course, as I said, you have a bachelor and master degree in mechatronics, robotics, and automation engineering. So I want to know that.
Yeah, I mean, initially, I would say both my co-founder and myself, our background is like hardcore tech. So we have a bit of a similar background. As I said, like mine was more like control, planning, and computer vision. His was more like computer vision and AI. So we basically had this, like the tech side pretty much covered. However, then doing a startup and building it, I would say a lot of learnings as well. I mean, number one, you constantly need to learn more about the technologies and how to building something for research, for example, is quite different than building it for like industry or, for example, a use case like agriculture, where you're literally working in the dirt in crazy environments all the time. So from the tech side, this was also definitely learning. I think something we definitely knew from the beginning. One of the things we actually knew from the beginning, because I think everything else we had to learn on the go. But that it's in research, if you do something and it works like 9 out of 10 times, this is a great achievement and you can make a paper about it and it's a cool like proof of concept. But let's say you do like the first thing we started with was like getting the systems aware of their environments, avoiding obstacles, flying around things, navigating initially even without GPS, etc. This initially worked like super great and we basically tackled it. But then getting this like 9 out of 10 to 1,000 out of 1,000. This step is really takes a lot of commitment, effort, iteration, and development. And yeah, this is, I think, one of the big achievements I think we actually achieved in our journey, to make a system that is really easy to use, but also is reliable enough that you can actually give it to people, that they can use it without any human intervention, ideally even, and it just works. And I think that is one of the big problems. But then, of course, like founding a company is not just basically building cool tech, but there's so many other skills involved. You have to constantly like interact with customers, learn from them. So not just sit in your garage and basically build something and hope that somebody will actually like it and want to have it and it's useful for somebody. But you really have to get out there, talk to people, talk to customers, get their feedback in, learn from them what their actual pain point is. So it's not just, I have a cool solution for you, and then they're like, yeah, but I actually have this problem. This was also, of course, a big learning to really be out there, talk to people, learn from them as much as you possibly can, learn from other founders, startups, and the whole business sides about it as well, of course. So yeah, I think the tech side we really brought in, and then everything else we really had to learn as we went.
Yeah, because of course you need to know what is the work of the people, what they are, the actual real problems they have, so you can improve your product for them to be useful, right? So
exactly,
I think it's really, really important that too. Now that we are talking about what Suind does, how this technology helps with early detection of crop stress before it becomes visible to the human eye.
Okay, that's actually a good question. What we do, so I mean, there's multiple approaches how you can do it. Our thought process was that we wanted to do something that you can really deploy in larger scales. So one thing, for example, is, I mean, you can take samples of leaves, send them into a lab, get them analyzed. But this is a really time-consuming and then, of course, very costly process, for example. Soil sensors is also great. Often you can even scatter them around, but they don't work in all use cases. And what we decided to use is building our own like multispectral and thermal camera-based drones for the analysis part. We then also have like the spraying part as well. But so the one product is our analysis drone, our mapping drone. And there we basically have our custom-made multispectral sensor. So it uses 4 specific kind of wavelengths from the light. So it filters just out these wavelengths, added in thermal radiation as well, and stereo imaging for mapping the terrain. So number one, you get like a 3D map of the environment, but then overlaid to this in 3D, you have the multispectral data. And for example, a plant, when it is stressed, reflects different relations between for example, near infrared and red light. Or when there's like water stress, you can detect this, for example, in a thermal range. So by analyzing these different channels in the magnetic spectrum, and especially comparing the relations to them, and then how these relations change over time, and compared to maybe the plant next to them or the field next to it, you can really see differences in the crop where there's problems or how trends are occurring over a growing season. But it's actually quite a challenging thing. For example, in plants while they grow, for example, if you talk about wheat, at the end of the season, it dries out. So in theory, it's a very like stressed, dry, non-healthy crop, but that's the positive thing. It has to do it. So it's not just basically having the data and then blindly applying some analysis to it, but you also have to actually understand the specific crops. How do they grow and what is the cycle? So it's not just a technological endeavor and technology you have to build, but then you also have to, of course, work with agronomists and take them into the boat that they can actually also make sense of this data, and then you can learn from them and start using their knowledge to build your products as well.
Yeah, of course, because as you said, it's not the same one plant from the other, so you have to have the knowledge how they grow, how they stress and everything, and compare with other things too. And of course, you have to work with the hand next to the agronomers too. Yeah, that's really true. Well, I saw you were in Japan 1 month ago, I think, and talking about AI and robotics that improves sustainability, efficiency in agriculture. So I want to know, what are the environmental benefits of using Suind's AI and robotics?
I mean, I would say it's a bit of a multifaceted approach, depending also which product you talk about, and then talking about the entire solution together. So number one, if we just, for example, our first product right now is also like our spraying drone. So with this, we're actually going to enter the market very soon. So we're soon going to do our first like official sales from it. There, it's really cool because even if you just compare to traditional methods, or if you say, okay, you're spraying the same compounds that you always did, not even going into biological farming where there's actually a lot of benefits of using this tech as well. But just from the combination of how the spray is dispersed. So we basically put also a lot of effort into developing the nozzle system on the drones themselves. So it's a kind of atomizing nozzles, which already creates like fine droplets and mist out of the spray. But then you combine this, for example, with the downwash from the propeller. So I mean, in our case, we have a pretty compact system actually for a spraying drone, but still it's a super strong wind pushing it down. So this creates like a mist, like this nanometer level, like super fine droplets, and they just get pushed in every nook and cranny, cover everything super evenly. And this means you actually need a lot less chemicals and magnitudes less water to actually spray. So just by that, not even talking about analysis, targeted spraying also, you can normally often even use like 70-60% less of the pesticides that you would normally use.
Wow.
For example, we recently did a trial in rubber. We're waiting of all the results, but the initial results have gotten in, and we managed to reduce the dosage by 75% in a couple of fields, to which we're testing different concentrations. And at 25% of the chemicals used, until now, after the monsoon, they couldn't find any fungal infections. So after monsoon, they always have like massive fungal infection in rubber plantations. And with the existing methods, even though they use a lot more chemicals and gasoline and everything else, they already started seeing the fungal infection happening. So this is really cool about the spraying technology in itself. But this is also really cool for biological agents, because they're normally less potent than the classical like chemical ones as they're normally labeled. Because there you normally need a really fine and even coverage on the plants. So this is directly again linking into the system where you're creating this. And then of course, because the distribution is so rapid and easy, you can more often apply them. For example, in vineyards, if they use bioagents, they have to pretty much every time it rains, they have to reapply them. And if they use those like tractors, sometimes even like self-pushed ones or driven ones, they compact the soil. It's really tedious to do. The farmers are exposed to the mist themselves in the middle of even if it's not like classical chemicals, but still like the compounds, it's not a great job to do. If you have a drone, you just let it fly over the fields, and the job is done. And so it makes it more lucrative to switch from classical to bio, because the distribution is so much easier and cheaper.
Yeah.
But then if you combine this again with the analysis, then it becomes really powerful. Because with this, then you can actually see in the field where you have problems, detect them early, and also where the problems are occurring. So you don't need to spray the same on the entire field. So you can simply pick or adjust your spray rate specifically where it's needed, or ideally just spray where you basically have something popping up. And again, it's rapid with a drone. You don't have to walk through maybe like hectares or hundreds or thousands of hectares of field. You can just have the drone flying over it, scanning it, mapping it. It does it all by itself anyway. So there's not a lot of human labor needed to do the operation. Just basically safety pilot, holding the controller, maybe drinking a glass of don't do that. And the drone is just doing everything anyway by itself. The data is transferred into the cloud, the processing happens, you see the data afterwards of the entire field, you check for problems. If problems are detected, you send out the sprayer. It exactly follows the maps generated by the analysis, just goes where it's needed to. And this just becomes like a really scalable and efficient process where you can significantly then reduce everything you put into the fields, and you have an actual oversight.
Yeah, that's really cool, because of course it's important also to preserve our planet and all the biodiversity that we have, to create something that is friendly for the environment too, and it's easy to use and it's helpful to know. So I think it's really, really cool. I was impressed by all the information that you are giving.
I hope it's not too much information.
No, it's fine. It's perfect. For me, it's perfect. And I know that for people that is going to watch it is also really, really helpful too.
I think just like one aspect that I really started to appreciate about agriculture is simply the matter of scale. Especially I recently was actually at Swiss Next from Switzerland and Brazil. We did a really cool tour through Rio, Sao Paulo, met a lot of agro specialists, and also while in India talking to people there and realizing the scale of agriculture, especially in these kinds of countries. It's massive. There's so much land area being used for agriculture. And this also means if you want to do something that actually creates an impact, you have to create a product that can be deployed on scale. I think this is something, especially in agriculture, that one really has to put their mind about, like the massive scale of these operation and farmland. And there, I think automation is simply the key, and a system that you can really easily teach people how to use, that they don't have to put a lot of brain power in and becomes fatiguing. So you want somebody to be able to operate a system for 8 hours or more a day, and then just service massive amounts of area, and then keep doing this all the time, over and over and over again. So for this kind of scenario, you really need full autonomy. Otherwise, it's simply not possible to make an impact there. And I think this is something that we really try to tackle. And that's the cool thing, also other startups getting into the space of automation. And I think this is really also the future of making impact in agriculture, that we have to think about this scalability of the products. So anything then also from data gathering and data management has to take this aspect into account. That is quite, I think, unique in agriculture, actually.
Yeah, that's totally true, and like as I said, it's really helpful for the agronomers and the people that is working in this, because as you said, it's impossible to have one person to do during the whole day all the process that they have to do. So I think it's really helpful. Talking about this, the name is Agrim X, if I am wrong.
Yeah, that was our first version. We actually
okay.
Little sneak peek. That was our first prototype. We haven't released the new one yet, but our actually product launch is going to happen soon.
Okay.
Going to have a different name, and
I think I read something on the website. There is the high resolution drone.
That's another one. There's 2 things coming out soon.
Okay. Another one.
Those people who have been following us or are going to follow us, there's like 2 actual like really cool products coming out very soon, shortly after each other. And yeah, Not going to say too much now, though.
Okay, don't worry. But I want to ask, talking about the AGRIM X, that is the one that is now, what challenge do you face developing that? Because as you said, is have own autonomy, has precise navigation, safe landing, obstacle avoidance. So I imagine it took many tests to achieve it, and it was hard to do it. So tell me, what challenge you face it?
Okay, I would lie if I would say that during the development process there were not a couple of drones at least hanging in trees, for example. I mean, you test it until you break it, and well, once you break it, you figure out how you stop it from breaking. So that is definitely part of the engineering journey. Can be frustrating, but also a lot of fun.
Yeah, of course.
But yeah, definitely. I mean, it was quite a long journey. Like I said, getting those systems reliable is the major challenge here. And then also like these kind of drones, I think that was also like why for a long time we didn't see drones in any industry, and then suddenly they did start popping up in different industries. Was you need a certain level of sophistication in the systems that it actually becomes viable. Because if the technology is not ready, the product is literally useless. For example, if you fly a drone and every 10th time something fails, it crashes, it just becomes more of a hassle than actually a useful technology.
Yeah.
So, and the drone it looks simple from the outside always, because I mean, it's 4 propellers and it flies, so can't be that difficult. But it actually is a very complex system that is flying. It's super agile. It has a lot of parts and components, and you can't just, for example, think about just software or just hardware, but it's really the interaction between those two systems, and every component has to be reliable, has to work and be adapted to each other. So for example, we are working with computer vision, so our drones fly pretty much completely. We also have GPS on board, but we use cameras to navigate in the world with the drones, so they're seeing. But then of course you take them into agriculture where it's dirty and there's like spraying, so they're literally putting stuff in the air. So there's all those little challenges coming, and reliability of, you're talking about motors, batteries, and the frame. It has to be ergonomic for the people. It has to look good. And of course, again, talking about the scalable thing, and especially agriculture, it's very price sensitive. I mean, if you build a drone that costs, I don't know, $100,000, pretty much no farmer except for maybe some giga farms in Australia or the States can afford this kind of system. And we wanted to make an impact, especially also in developing countries where there is a lot of agriculture also happening, small scale farmers, bigger farms. So building something that works well and then is also cheap enough that they can really afford it and want to buy it, because the return of investment is just so much higher than the capital cost for them. And not just an expensive system for like the wealthy West, but for the entire world. And that was something we decided from the get-go, which I think I'm really glad we did, because we always had this price constraint in our mind. But it's something that also, of course, raises the bar of challenge, because making something expensive and big is easier than actually keeping it cost effective.
Yeah, that's true. I think that this is the best deal. Like works really good and it's not so expensive. So like it's a really good deal for everybody.
Normally, I mean, if you think about, normally it's like opposing factors with each other, like high quality, reliability, cost effective, they pull on each other. But you have to make it both happen at the same time. And
yeah, that's true. And well, talking about like challenge and today's business, I want to know which challenge you face, but now talking about procurement process that you have, and probably what strategy that you use to ensure your supply chains remain resilient and adaptable during these days, during the last years.
Okay, I must admit, luckily we were not in large scale production back then, but during the semiconductor crisis, it's something you normally just read in the newspaper and don't really think about. But we actually noticed during our development period, we suddenly really struggled getting the components in, which was kind of it was a crazy moment actually for us, because it was the first time for me personally that like global supply shortage or something was actually affecting me in my daily life. Luckily, that is over now. And for example, manufacturing, we have a really cool manufacturer we are basically we're in charge of the entire product line, but we are like software specialists. So we have a manufacturing partner and we have a really close relationship with him. He's doing amazing work there. So I think building close connections with the people you're working with, you're depending on, is really important there as well.
Yeah, like your
but then of course there's other like components that you basically, I mean, we are a small startup, so we're not making everything from scratch. That would be too costly and time consuming for us. But in that sense, we of course try to make sure that there's always an alternative to something. If we get something off the shelf, that there's another manufacturer that does something that we can basically replace this component with. So we wouldn't need to stop simply because one manufacturer suddenly has a problem.
Okay, and you have something that helps you with the procurement process or everything, or maybe not?
Not really yet. We're not in large scale production yet.
Yeah.
So I think this will be another learning for us of how to properly manage this entire process as we scale our production up to basically larger and larger numbers.
Okay, well, yeah, I think it's crucial. Well, for now, you said that you don't have a big scale of production, but I think that it's helpful for to have something like maybe in the future to help you with the procurement process, to make everything easier, efficient, and you can focus just on developing the features, the best products and services, of course. Well, talking about that we already talked about it, but I want to ask again, if you can have like a little spoiler, what is coming, the features that is coming from Suind. As I said, like the high resolution drone, then you said that you have another one that is coming too. Maybe a little spoiler about that. What can users expect from that?
I would say the next thing we're actually going to release, and it will be our, I would say, first real release into the market, is basically, I'll just call it the successor to AcromX. So that was it was more like a prototype system, and the actual system is going to come out very soon. We were going to share like some videos also very soon of it, and yeah, I'm actually really excited. I can't actually wait for that to happen. The whole team is like non-stop working on that part, and yeah, this is so the successor of our first ever system and our first product release. It's going to happen in the next 1 or 2 months, I would say.
Oh, well, that's really cool. I can't wait to see how it goes too, and the impact that we'll have. So I will be expecting for that news. And well, to finish with this interview, I like to close it with a question that I think can help some people out there. Is there any advice that you will give to the young entrepreneurs that are starting their own journey now, as you did years ago?
Definitely be prepared for the long run. If you start out, you often think it's a quick journey, especially if you develop hardware. Hardware is hard.
Yeah,
I would say worthwhile. But I think it's worthwhile because I mean, creating real products that can create an impact in the world is definitely satisfying. I love working in a field where you can actually give something into people's hands that make their life better. That is a big factor for me that keeps me motivated to push through the challenging times. But yeah, I think since being an entrepreneur, there's always challenges to really find something you're passionate about, and that it's not just being money motivated, but really finding a passion where you find a problem.
Yeah, something that moves you.
Yeah, where you really wanna solve it. You really wanna help people with it, and that just pushes you forward and makes you go beyond what maybe others would be doing or where others might quit. And then you just keep going to reach that target line, to make this impact, to create what you envision and you dream of. I think that would be my advice.
Well, yeah, that's really good. And well, thank you so much, Kevin, for being here and sharing all your experience with us. It was really helpful to hear your ideas, all what is Suind coming soon too, and where we can find you and Suind, any social media handles or website.
I think the best thing right now is always on LinkedIn. Just like follow us, or us personally and Suind in general. We're trying to get our YouTube channel a bit up and running as well, but right now it's a bit stagnated. No, but LinkedIn is always perfect. Soon a new website as well, and see what we are going to do in the future.
Okay, perfect. And for everybody that is watching, remember that you can find more information, interesting articles, and interviews directly on our website, buildernation.io, and as Builder Nation on LinkedIn. Thanks again for being part of this community. We will see you in the next episode. Thanks again, Kevin, for joining us.
Thanks so much for having me. And thanks for everybody watching. Bye.